right, this is for Unit 3, Day 4. What if the expression cannot be factored? So we've worked a lot so far on reviewing all of the factoring methods that you have learned up to this point. Not all quadratics or not all polynomials are factorable. So here's an example of one that is not factorable. If you're using, a typical factoring thought process, you would be thinking of factors of 1 that add up to 7. Well, the only factors of 1 are 1 and 1. There's no way to get that to add up to 7. So this particular polynomial is not factorable. Now, just because it's not factorable does not mean that it doesn't have a solution. It just means that it doesn't have a rational solution. So what that means is that the solutions are probably going to be either irrational or they might also be non-real numbers like imaginary numbers, which we'll get into in a minute. So you might remember from last year that if a quadratic is not factorable, we can use the quadratic formula to find the solutions. So if ax squared plus bx plus c equals 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac, and that is all divided by 2a. Now, what you should notice about this polynomial here is that it is in standard form. The highest power is x squared, and so it starts with that highest powered term, and from there it goes down to the constant. It is also equal to 0, and those two things are required for the quadratic formula to work. So let's look at one. X squared plus 3x minus 2 is equal to 0. If we tried to factor this, we would be thinking, what are the factors of negative 2? And the only way to factor negative 2 would be either 2 and negative 1, or, or it possibly could be negative 2 and positive 1. But really, that's the only two ways to factor negative 2, and neither of those combinations adds to 3. So this is not factorable. If it is not factorable and you want to use the quadratic formula, the first thing that you need to do is identify what a, b, and c are for your equation. So it looks like our equation is currently in the correct form. Our a in this equation will be 1. B is the number 3. And our c is going to be negative 2. And the negative definitely is important there. So quadratic formula tells us that if we want to solve this equation, then x is negative b, so in this case negative 3, plus or minus the square root of, we want to take b and square it and subtract 4 times a times c. C is negative 2, and that whole thing is going to be divided by 2 times a. So the negative 3 I'm going to leave alone for a minute, and the denominator is 2. What you want to do now is leave that radical and figure out what this quantity inside the radical is. And you can use your calculator to calculate that if you need to, or you can think through some of them if the numbers don't get too gigantic. But again, you can use your calculator here. 3 squared is 9. And then we're subtracting 4 times 1 times negative 2, so that's the same as adding 8. So this is the square root of 17. And square root of 17, I can't really simplify a root 17 at all, so this will be my final solution. And there are 2 solutions here, please note, and you don't need to necessarily write them separately. I just want to remind you that this is 2 solutions. The first one would be negative 3 plus root 17 over 2. which if you type that into your calculator is about uh, 0.56, I think. And the other one is negative 3 minus root 17 over 2, which if you type that in your calculator is around negative 3.56. So these are both real solutions. They just are irrational solutions. But it does have two solutions. It is fine, of course, like I said, it's totally fine to leave your answer in this form. I just wanted to remind you that what those two solutions look like. So as you are using the quadratic formula to help you solve polynomial equations, you need to be really good at simplifying radicals. That's just really important. So in class, we did a couple of refreshers on simplifying radicals and on complex numbers. I'm going to make a separate video of that. So if you want to watch that video or if you feel comfortable with radicals already, you don't need to. But I'm going to go on now to more examples of quadratic formula. We're just going to do, I think, 5 more or so, just to make sure we've sort of covered our bases. So again, x squared plus 6x minus 10 is the equation we want to solve. It's equal to 0. I need to identify my a, b, and c. In this case, a is 1. B is 6, and C is negative 10. So if we put those values into our formula, it tells us that x is equal to negative b plus or minus the square root of b squared minus 4ac. And that's all divided by 2 times a. You might have noticed I have been putting my b in parentheses. I almost always will do that just to be careful, primarily because if b is negative, it's really important that you have those parentheses, and we'll see one of those in a second, but it's just kind of a good habit to have. So if we work to simplify this just a bit, we have a negative 6 plus or minus a radical over 2. And that radical, 6 squared, is 36. And we're subtracting 4 times 1 times negative 10. That's the same as adding 40, so it's 76. Again, you can use your calculator for that. So at this point, you want to take a look at your radical and think about whether or not you can simplify that. Well, the square root of 76 is what I'm trying to simplify. Another way of writing 76 is that it is 4 times 19. But we know the square root of 4 is 2, and 19 is a prime number. We can't simplify the radical of 19 any more than it already is. So this 2 root 19 is what the root of 76 simplifies to. So let's add that into our formula here. Negative 6 plus or minus 2 root 19, all divided by 2. Remember, when you have a denominator like this, it's kind of the same as having that divided by 2 with both parts. So I'm going to separate that for a minute to sort of show you that I could reduce this term right here by a factor of 2. If I cancel or reduce a factor of 2, this is going to be a negative 3. And then this factor of 2 would also reduce. So that means x is equal to negative 3 plus or minus root 19. And there's my two solutions. I don't always like to separate it this way, but I think on this example, separating it is probably the easiest because you can really see that that 6 over 2 is a 3, and you can really see that those two would reduce. In a minute, we'll look at some other ways of thinking about those. Okay, another one. We'll just keep doing these until we want to die. Not really, it's fun. Okay, so for this equation, 3x squared plus 5x minus 2 equals 0. A is 3, b is 5, c is negative 2. So if we use the quadratic formula here to help us solve it, x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, and that is all divided by 2 times a. Let's simplify and figure out what is inside that radical. Negative 5 plus or minus, this is all over 6. Well, if we're simplifying 5 squared minus 4 times 3 times negative 2, that's the same as 25 plus 24, which adds up to 49. Again, you can use your calculator. Negative 5 plus or minus the square root of 49 all over 6. You know, I know the square root of 49. The square root of 49 is equal to 7. So x is equal to negative 5 plus or minus 7 over 6. How interesting. I have no radical. If you get an answer like this, what it really means, and I'll show you what the answers are in a second, but what it means if you get to this point where you no longer have a radical or an I or anything, it's just a few numbers, it means that the quadratic was actually factorable. So this one we could have solved by factoring, but if you get stuck and you really can't factor one, you can always go ahead and use the quadratic formula as long as it's a quadratic, as long as it has power 2 as its highest power. So if you have an answer like this, you really should keep going. This is not simplified all the way. So I'm going to split this apart into the two solutions. Negative 5 plus 7 over 6 and negative 5 minus 7 over 6. Well, this top one, negative 5 plus 7 over 6, well, negative 5 plus 7 is 2, so that's 2 over 6, which I can reduce to 1/3. So that's one of my solutions. For the other one, negative 5 minus 7 is negative 12, and that's still over 6. And if I simplify that, it's negative 2. So here are my two solutions, 1/3 and negative 2. A second ago I said that if we get an answer like this, what it means is that we could have factored the polynomial. So if my solutions are 1/3 and negative 2, guess what my factors would have been? The factor that goes with negative 2 is an x plus 2. The factor that goes with x equals 1/3, well, that's going to be a 3x minus 1. So this is what our equation would have looked like if we had factored it, and then we could have gotten the answers from the two factors. Okay, another one. Now this one, you might notice, is not yet equal to 0. So remember that we need to have our quadratic in standard form equal to 0 in order to solve it. So I'm going to sort of move everything to the other side of the equation here. So I'll have a 3x squared minus 2x and a minus 7. These ones will reduce to 0. Now, none of those terms combine, so we have to just write them out as separate terms, and I wrote it in standard form. So now that it's in standard form, we can identify our a value is 3, our b value is negative 2, and our c value is negative 7. So we can use the formula here. X equals negative b plus or minus the square root of b squared. This is where it really matters that you have those parentheses. Minus 4 times a times c, and this is all divided by 2 times a. Well, a negative 2 is just positive 2. And now we need to know what is inside that radical. Well, negative 2 squared is 4, and we're subtracting 4 times 3 times 7, and that would be a positive 84. So it looks like the number inside of our radical is 88. And again, you could use your calculator for that. So 2 plus or minus square root of 88 over 6. We can simplify square root 88. And if we're thinking about simplifying a radical, we want to think about a way to factor that number using perfect squares. 88 is 4 times 22. So we know the square root of 4 is 2, and that root 22 will stay. 22 is 2 times 11, so there's no more perfect squares in there. That is as simple as it gets. So let's replace root 88 with the equivalent to root 22, and that's all divided by 6. Okay, so we can continue to simplify this one a bit more. We have a part over here, a 2 over 6, and then this part is also a 2 over 6. Now that divide by 6 applies to both parts. There is a common factor of 2 in all of those parts though. So we could think of this as a 1 over 3 in the first position, because 2 over 6 is the same as 1 over 3. And in the second position, we also over here have a 2 over 6, and that also reduces to a 1 over 3. So we have 1 plus or minus 1 root 22, and that's all over 3. Or you could really write it without this 1 in front of the radical. So 1 plus or minus root 22 over 3 would probably be the most proper way to write that. Just remember, if you have a denominator here, it does apply to both parts. It's not just the first one and it's not just the second one. It applies to both parts of that number, plus or minus a number. Okay, let's see. We're on 5. We've got one more after that, so we're almost done. Here again, we have an equation that is not equal to 0. So we're going to have to manipulate it just a bit to get it equal to 0. 2x squared minus 3x plus 5 is now equal to 0. So our a is 2, our b is negative 3, and our c is 5. So if we put that into the quadratic formula, we have x is equal to negative 3. That's going to be positive. Square root, don't forget the plus or minus symbol, square root of negative 3 squared, that's our b squared, minus 4 times a times c, and this is all divided by 2 times a. So that negative 3 is positive 3. Inside our radical we have 9 minus 4 times 2 times 5 is 40, and that is a negative 31, all over 4. So if we continue to simplify this, well, the number 31 in itself does not simplify much, a root 31, but a negative root 31, a negative square root, and I am not spending a lot of time on how to simplify square roots in this video. I will make a separate video for simplifying radicals. The negative here, square root of negative 1, let's see, I'm going to write it like this. Negative 1 times 31. Well, the square root of 1 we know is I, so this is an I root 31. So we can replace that in our equation, that root negative 31. So it's a 3 plus or minus I root 31 over 4. And there's no other perfect squares in the number 31, so that one will stay. So there are our two solutions. These ones are imaginary. They are called non-real or complex solutions. And there are two of them still, they just are not real. Okay, last one. Says it's kind of sort of difficult, but I don't think it's too bad. The equation itself does look a bit complex. We have 2x cubed plus 10x squared minus x is equal to 4x squared minus 3x. And remember, when we're dealing with polynomial equations, the reason that factoring is powerful and the reason that we can use factoring in our favor is because of the zero product property. So we want our equation to be equal to 0. We'll subtract 4x squared, and we'll add the 3x to their like terms. We have an equation equal to 0 now. 2x to the third power plus, let's see, that combines to a 6x squared, and plus a 2x. Now, as you're looking at this equation, I hope that you notice that those three terms have an awful lot in common. They have a 2 in common for sure, and they also have a factor of x in common. So if I factor out a 2x in this first position, I factored out the 2, I factored out one of those x's, I'm left with x squared. In the second position, I've got a 6x squared. Let's see, we factored out a 2, so that'll leave a 3 inside. And I factored out one of those x's, that will leave just 1 behind. And I'm factoring out a 2x squared from the number 2x squared. And it is helpful to think of that as 2x squared times 1, and that will leave a 1 inside the parentheses in that third term position. Remember, when you're factoring out like a GCF of something, your expression that's left behind should have the same number of terms as the one you factored the GCF out of. So we've got a factor of 2x and a factor of x squared plus 3x plus 1. So perhaps we try to factor this thing, and we're starting to think of factors of 1. We want them to add up to 3, and darned it, there are not factors of 1 that add up to 3. So factoring is not going to work here. We will have to rely on the quadratic formula to solve this portion of the problem. So essentially we've got two factors right now. We have a factor of 2x. Well, when will 2x equal 0? Well, the solution to that is when x equals 0. So we have found one solution already. You might notice that for this equation, our power was 3, so we should be expecting 3 solutions, and we need to find 2 more now. The other 2 are going to come from setting this second factor equal to 0, x squared plus 3x plus 1. It's a quadratic factor, but it still could count as a factor. So we're going to solve x squared plus 3x plus 1. We need to use the quadratic formula to do that because it is not factorable. A is going to be 1, B is going to be 3, C is going to be 1. So if we plug those values into our formula, we get x equals negative 3 plus or minus the square root of 3 squared minus 4 times A times C. And this is all divided by 2 times A. And if we simplify that a bit more, we get negative 3 plus or minus inside of our radical. We have 9 minus 4, which is 5. Again, you can use your calculator for that. And this is all divided by 2. So we pause to think about the radical. We have a root 5 here. Root 5 is not simplifiable in terms of that radical. The only factors of 5 are 1 and 5. And so we cannot simplify this anymore. So here are our 2 additional solutions. Again, we have a total of 3 solutions. We have 0, and we have negative 3 plus or minus root 5 over 2. Okay, so that's it for our review of radicals. And our review of how to solve non-factorable polynomials. I will make a separate video that is on simplifying radicals. If you need help with that, you can watch that one. That is all for now.